The focus of this lesson is on graphing an exponential function. So an exponential function, recall, is just your f of x equals some base to your variable power. And your variable power is your independent variable. And if you can raise your base to a negative power, a zero, a positive power, so it makes sense that that independent variable could take on any value. So your domain for your exponential function is all reals. So that helps as far as knowing graphically what happens. When you're dealing with an exponential function, you will have a horizontal asymptote, and you typically want to come up with 3 key points to help you graph. And so typically what I do is I pick my x's and to be -1, 0, and 1. And those are basically my powers at the end of the day. So when I get my y's or my f of x's back, it's just whatever my base is raised to the power I just wrote. So what is 1/7 to the -1 power? And the answer is, it's going to be the reciprocal, so it'd be 7. What is 1/7 to the 0 power? Well, anything to the 0 power is 1. 1/7 to the first power, well, it doesn't change anything. It's 1/7. And so you can see your 3 key points are -1, 7, 0, 1, and 1, 1/7. Notice that those 3 key points are in terms of the base. I mean, 0 is always paired with 1, but otherwise -1 is always paired with the reciprocal of the base. 1 is always paired with the base itself. And so then if you go to graph this, -1, 7 puts us here, 0, 1, and then 1, 1/7. And then as you continue on, if you continued on with your power, like 2, 3, 4, you would get smaller and smaller and smaller, but you would never hit 0. And so you approach that x-axis. And so this is exponential. And so it has a horizontal asymptote at the x-axis. So it has a y equals 0 is your horizontal asymptote. And so that's graphing with 3 key points. We can do one more example, but this time around our base is e. So our points are going to be in terms of that e. So again, we'd still pick our x to be -1, 0, and 1, but it's e raised to those powers. So e raised to the -1 is just going to be the reciprocal, which is 1 over e. E raised to the 0 power, anything to the 0 power is 1. E to the first is just going to be e. And then 1 over e is approximately 0.37, which you can see on the left there, that I have it defined as that. E to the 0 is just going to be 1, and we already said that, but I'll just rewrite it again. And e to the first is approximately 2.72. So again, your points, and I'll rewrite with the actual exact values in, just so we can see again. What I want you to see is 0 is again paired up with 1, and that's what always happens with your exponential function. But notice -1 is paired up with the reciprocal of your base, and 1 is paired up with your base itself. And that will always be the case. So then if you go to graph this, -1, 0.37, you're getting close to 0 but not hitting it, 0, 1, and then 1, 2.72. You can see that your curve kind of is going a different direction than the last time. But again, you're approaching that x-axis but not hitting it, and so you still have a horizontal asymptote at y equals 0. And so this is your exponential graph. So in both cases you can see that the domain is all real numbers. And I'll go ahead and list that for the second graph as well. It's all real numbers as well. You can see in both cases the horizontal asymptote is y equals 0. You can see that the range, well, you approach 0 but you don't hit it, and then your graph shoots up to positive infinity. So you're going from 0 to infinity in both cases. That could change if your graph was reflected, let's say, over the x-axis. But again, and then note that your 3 key points, one of them is always 0, 1, the other one is -1, reciprocal of your base, and then 1 comma your actual base. So it's important to pay attention to who your base is, because that determines your 3 key points. And that's how you go about graphing an exponential function. If you need to read over the details more thoroughly, look at how I define an exponential function off to the left here, along with the natural exponential function. And the natural exponential function is the one we just graphed with base e, and base e is approximately 2.72, and that's Euler's number.